Welcome to our presentation on electric arc flash and arc blast hazards. All right, this is what we're going to be going over in this presentation. First off, what is arc flash and what is arc blast? Then we're going to go into some case studies and stage testing. After that, we're going to go through arc flash regulations, some lockout, tagout, and worker limitations. And finally, we're going to go through how we go about doing an arc flash assessment and what the requirements are for PPE. There are three big electrical hazards: electric shock, electric arcs, and electric blasts. As you can see, electric arcs and blasts are 75% of all the injuries that these three hazards can create. An electric shock can happen anytime when voltage passes through someone's body. Shocks can cause internal burns, and over time these burns actually worsen. It takes an extremely small amount of amperage to actually kill a human being. Every human has different physical characteristics which will determine how you will be affected by the shocks. And you can also get shocked from things that you might not expect. There's some electrocution percentages through voltage ratings. When you have low voltage work, 120 volt to 240, you can see we're down or up at 54%. The only other higher percentage than this is whenever you get into high voltage work at 7200 volts to 13.8 kilovolts, where you're at 76%. But the key point here is that 3 times as many people are electrocuted at home as are killed on the job. A lot of this is because you're going to be safer whenever you're working. You're going to wear the correct PPE, and you're going to be more prepared to deal with these hazards than you are when you're working at home. Because anyone at home can be working in their fuse box, whereas only qualified employees can be working in the field. There are ways that we can protect from shock other than personal protective equipment. Unqualified personnel must stay at least 3.5 feet away from exposed electrical equipment at all times. Third prong equipment, which grounds the equipment, it can help from an electrical shock. And the other answer to that is double insulation. As you can see, the symbol for double insulation down at the bottom right there, and the illustration for a third prong adapter. Ground fault circuit interrupters, or GFCIs. That is a picture of one on the right there. If any unsafe conditions are at your facility, promptly report these. Okay, a little bit of vocabulary here before we get into the meat of this. An electric blast is a high pressure sound wave caused by a sudden arc fault. An arc flash is an extremely high temperature discharge produced by an electric arc in the air. Now, there's two different kinds of faults that can cause an arc flash and an arc blast. An arcing fault is an electrical fault where current flows through ionized air, causing an arc. Okay, this is when the energy is dissipated in the surrounding environment. And then a voltage fault is where an electrical fault flows through a solid connection. This is where the energy is dissipated in equipment. Or if you were working on equipment and you happen to drop a wrench or something on a bus bar, this could cause a voltage fault. The arcing fault can be caused through, in a steel mill, you have a lot of particles in the air that the arc can flow through to cause an arcing fault. Continuing on with vocabulary, the incident energy. Now, this is the amount of energy impressed on a surface a certain distance from a source that is generated during an arc event. This is measured in calories per centimeter squared or joules per centimeter squared. In our flash hazard analysis, we use calories per centimeter squared, but it's just a conversion factor to get to joules per centimeter squared. Also, you have flash protection boundary. This is the distance where the incident energy equals 1.2 calories per centimeter squared. This is the minimum energy that is required to produce a second-degree burn on someone. We'll be getting into flash protection boundaries later in this and showing you how far away people do have to stand to be safe. And also PPE is personal protective equipment. This is voltage-rated gloves, flash protective clothing, such as flame retardant coats, pants, a flash hood, and even getting into flash masks. Okay, what is an arc flash and an arc blast? An arc flash happens when an electrical arcing fault occurs. Okay, as current flows to the ionized air, causing energy to be dissipated around the surrounding environment, producing intense heat and light. The arc blast comes from the air surrounding the arc that is instantly heating, causing the conductors to vaporize, and this resulting in a pressure wave and a loud sound. This pressure wave and the sound can be as dangerous as the actual blast and the flash and the explosion. When can they occur and how often? Causes can be multiple things, from inadvertent contact, loose connections, insulation failure, poorly maintained equipment, voltage transients, unsuccessful short circuit interruptions, or even something as an animal running across. 5 to 10 arc flash explosions occur in electrical equipment every day. And this is just in the United States. And this doesn't represent, this figure does not represent cases where a victim is sent to an ordinary hospital. This is representative of what people report from their facilities. Many arc flash deaths are inaccurately reported as electrocutions. Each year, more than 2,000 people are treated in burn centers with severe arc flash injuries. Here's an illustration of some electrical burns. Electrical arcs burn the tissue from the outside in. Now this is unlike an electrical shock, where the shock will burn you from the inside out. There is no cooking associated with this like there is in shocks. You'll get burns on the outside, but it's just an explosion. It's just like any other fire that you would see. Arcs can immediately set fire to clothing, and so what you're wearing matters. And that is something that we're going to go over in this, is to show you what you should be wearing whenever you're working on this equipment. And lastly, you should not, well, obviously you're not going to try to inhale the gas, but you should get away as fast as you can without inhaling the gas, because these vapors can be dangerous as well. If an accident does happen, do not touch or approach the person that it happened to. Call 911 or an ERT number. Get a qualified person to remove the victim from the equipment. And lastly, report all shocks to your supervisor, no matter how minor they appear to be. Shocks or arcs. But the shock can have lasting value, whereas later you can have delayed fibrillation, where your heart can be affected by it. Here's a graph showing electrical fatalities. This is from 1992 to 2000. The red line illustrates the fatalities from people having contact with overhead power lines. The blue illustrates contact with wiring, transformers, electrical components. This is more your industry line here. The green line is showing contact with electrical current of machine tools or appliances, more of a home, your home injuries there. The first yellow line there is a contact with electric current, but that's unspecified. So that could be either one of the other two lines there. And the gold line, or orange line I guess there, is whenever someone's struck by lightning. The blue line is contact with electrical current, and the black line is contact with underground or buried power lines. As you can see, overhead power lines and contact with wiring and transformers is your greatest, and that's what we're going to try and bring down by showing you these hazards. Now, the probability of survival from a burn injury is going to vary on a person's age. As you can see at the bottom here of the graph, age 29 or 20 to 30, you're going to have from a 25% body burn, you're almost going to have 100% recovery. And same with age 30 to 40. As you can see, that drops off a little bit as you get into your 40 to 60 ranges. The real line that is important here is 75%. There's the most difference whenever someone has a 75% body burn. So just a little illustration to kind of show you that you want to be safe, especially as you get older. Even though you know more and you'll be more experienced, you still want to keep yourself safe. Okay, we're going to go through 5 case studies now that are going to illustrate what has happened in the past. March 24th, 2004, OSHA fines Piper Electric for following arc flash explosion accident, for the following arc flash explosion accident. The Occupational Safety and Health Administration cited Milwaukee-based Piper Electric Incorporated for 4 alleged safety violations following an electrical accident, which I announced that on March 24th, 2004. The agency initiated an inspection after an accident at Racine, Wisconsin, wastewater treatment facility where Piper was contracted to furnish and install electrical equipment. The September 23rd, 2003 accident severely burned 3 Piper employees when an arc flash and explosion occurred during testing of an electrical switchgear unit. From the November 2003 issue of EC&M, article involving obsolete plant electrical systems, when an electrician at a Cleveland industrial plant got the call to rectify a work stoppage situation by replacing a blown 480-volt fuse, he was unaware that the system he was about to work on included parts that were more than 60 years old. It had been modified in such a way that almost guaranteed disaster. As he stood on a man lift and replaced the fuse in an obsolete and defective bus plug in the ceiling mounted 480-volt bus duct, an arc flash erupted from the duct, engulfing him in flames and igniting his clothing. Although the flash only lasted a few seconds, that was long enough for him to suffer extensive burns that would kill him days later. From the January 2001 issue of EC&M, article involving case of the elevator arc flash. While servicing an elevator at an older San Francisco high-rise hotel, an elevator technician accidentally created an electrical arc flash at the fuse switch. This accident left him permanently disabled. During the arc flash, the helper's hand was on a connecting terminal on the electrical conduit between a 100-amp disconnect switch and its associated elevator controller. As the current went through the conduit via the fish tape, it heated and caused a thermal burn on the helper's hand. The fault current never reached a magnitude great enough to blow the 400-amp fuse powering all 6 elevators. No fuse blew during this incident because the fault current paths did not meet rules outlined in the NEC. From an incident report from California Department of Health Services poultry processing plant in 1991-92. The electrician took the cover off an electrical junction box where the factory equipment can be connected to a 440-volt power supply. Without testing it to see if the power to the box was shut off, and without putting it on his insulated gloves and face shield, the electrician touched the live connection and set off an electrical arc flash, so strong that he thought the box had exploded. He was burned over approximately 20% of his body on the face, neck, chest, arms, and his hair was completely burned off. And his fingerprints were found burned to the panel box. He died 5 days later from these burns. And lastly, you can find incidents documented as early as the 1960s. In the USS Ratner submarine, San Diego, California, an arc flash during a simple fuse replacement burns occurred, and this caused burns and 3 weeks of temporary blindness to a man on that ship. Now, to summarize these case studies, electrical workers rarely get a second chance to return to their previous job assignments following an accident. They're either killed or maimed for life. A combination of proper engineering, training, work planning, and protective equipment is essential to maintaining an electrically safe work environment. We're going to go through some stage tests now.